Okay, so let's do the question number 22. Question number 22 is actually this guy. Am I on the screen? Yep, it's on the screen. Okay, so basically you have this reaction right here, and then you're supposed to find the temperature range for this reaction to be product favored. Product favored means that it's spontaneous, going from left to right. Okay, so all of these informations from the table is given here. Notice that we don't really use the delta G here because that we're solving for the temperature, right? So when you're solving for the temperature, that means that there is no guarantee that the temperature is going to be at the room temperature, right? So we can't use delta G naught because delta G naught is only good for 25 degrees Celsius. But just like the last problem, the delta H and entropies is not really is not affected by the temperature as much as the delta G. So because of that, we can actually assume that the delta H and delta S to be somewhat constant over large temperature range. So we're going to use those two numbers from the table. So you get all of these information from the table, just like the last problem. I already did actually copy down the informations like so, but you can actually do it by yourself. Now let me just talk about what this problem is actually talking about. So let me just try to, well, maybe I should probably start actually calculating the delta H and delta S, right? So that's probably the start. That way that I can actually talk about a little bit better on the delta H of reaction and then delta S of reaction. So let's cover that one first. So equal the delta H. Right? Delta H is that I have product 2 times this minus all the reactant, that plus 0 plus 0. Good. Now I have the delta S of reactions too, I can calculate. So delta S of reaction is that plus 2 times that minus this plus 2 times that plus 2 times that, right? Now that one right there is a kilojoule per mole, and this is joule per Kelvin. I don't like the joule per Kelvin because they're different here. So I'm going to divide everything by 1,000. So that's equal to this divided by 1,000 kilojoule per Kelvin, right? Maybe that I should use capital K. So I have delta H of that, and then I have a delta S for that. That's a delta S, right? Good. Now I'm gonna put my note here. So delta G is always equal to delta H minus T delta S, right? And in previous example, I had this value to be 32.9 and then this value to be 0.23, right? Then whenever the delta G value right here, whenever the delta G value is less than 0, this reaction is spontaneous. So 0.1, it's not spontaneous. 0.01, it's not spontaneous. But as soon as it turns to negative 0.01, this will be spontaneous. When does it switch? It switches at 0, right? So we are going to find the temperature that's exact, makes the delta G to be exactly 0. So solve for this temperature right here. Anything higher than this temperature is going to make everything more negative. So everything is going to be spontaneous, right? So let's solve for this temperature right here. So rewriting these things, 0.23 T is equal to 32.9. Then T is equal to 32.9 divided by 0.23. So let's do that calculations. So the temperature, or the minimum temperature that needs to be there, is equal to 32.9 divided by 0.23, 143. That will be my answers for question 22. Yeah, it's 143K and up.